All right.
It's recording.
All right. So to talk about pH, pOH, and all that sort of jazz, we first need to look at a couple equations, and we have to memorize these. So for one, pH is going to equal negative log of hydronium. So that's H3O plus. And pH can also equal, and I'll put another one over here, pH also equals negative log of the concentration of hydrogen. So those are two equations we have to know in order to find our pH. Now, pOH is a little bit more different than pH in that our equation will be equal to negative log, or damn, that's a...
You cursed on the video.
Damn right I did. OH, hydroxide right there. So pOH, pH, those are the equations you just have to memorize. And at least you know that to find the pH or the pOH, it's just going to be negative log of whatever concentration you're given. So another equation you have to know is that pH plus pOH equals 14. So those are the main equations you just have to know, you just have to memorize in order to solve things like finding the pH given the hydroxide concentration, finding the pH given the hydronium concentration, things like that. So let's go through a problem real quick. So I'm going to say that my OH concentration, OH minus, is going to equal 2.5 times 10 to the negative 4 molars. So automatically when we see molars, that's indicating concentration. So we know that we're given the hydroxide concentration. So we can automatically use this to finding our pOH. So all we have to do is negative log of 2.5 times 10 to the negative 4. And that gets us
Just
Go ahead and edit that.
Oh my god.
we got 3.6. All right, so we got 3.6, but that's our pOH. And I'm going to put pOH. So this is our pOH. We're trying to find pH, not pOH. Now, you might be wondering, well, how do we find pH given pOH? That's where this guy comes along. So pH, if we rearrange this equation with basic algebra, pH is going to equal 14 minus pOH, and that would just be 14 minus 3.6, and that should be, what is it, 10.4. So pH is going to equal 10.4. So let's break down the sort of steps that I went through in order to sort of solve this problem. So first thing I ask myself is, what concentration am I given? Because I see molars automatically, which just indicates concentration, or you can even ask yourself what you're actually given. So I'm given the concentration of OH. So automatically I'm thinking to my head, thinking in my brain that I could use this concentration of OH to find pOH. That's the only way I could use this concentration in order to get close to pH. So with OH, you gotta go through a couple more steps than if you had hydronium or hydroxide, because if you're given the concentration of hydronium, then that's pretty easy. You just negative log that thing and that's your answer right there. But when you're given hydroxide, you're given any of these basic sort of concentrations, then you have to use pOH. So automatically just plug that in right there, so negative log of OH, and that got me 3.6, but that's my pOH. So I realized that I'm trying to find pH, not pOH. So it's just 14 minus pOH, which got me 10.4 as my pH. Let me see what this looks like real quick.
You keep doing what you're doing.
Or actually, you got a question?
Yeah. So now that you have your pH, if you were to try to find the hydronium concentration, how would you do that?
Okay, so to do that, let me erase all this stuff over here. If we wanted to find the concentration of hydronium given pH, we have to rearrange this. Now, to rearrange this sort of equation, let's just do this. pH, and I can take this one out because we don't really need it. So rearrange this first, divide by -1, just to get that negative out. So when we do that, that's going to be a positive log over here. We're going to have a negative pH. Now in algebra,
Don't you take the 10 to it? Like 10
exactly.
To the power? Okay.
Yeah, so you do 10 to the power of, 10 to the power of. This cancels that out, so then your formula is 10 to the negative pH equals your concentration of hydronium. Same thing for pOH, which would be 10 negative pOH equals the concentration of hydronium.